Okay, so identify and explain oxidizing agent and reducing agent. Okay, let's use this first example, right, which is to gain or lose oxygen. Okay, so in this example, carbon is oxidized to carbon monoxide as it gains oxygen. Okay, so CuO caused carbon to gain oxygen. CuO is the oxidizing agent. Okay, carbon is oxidized to CuO. From this equation you can see. So CuO caused carbon to gain oxygen. So this is the oxidizing agent because it causes your carbon to form CO. Okay, so CO is the oxidizing agent. Okay, so what happened to CuO, CuO loses oxygen to form Cu. So CuO is reduced. Okay, let's look at this again. CuO is the oxidizing agent because it caused the carbon to gain oxygen, and CuO lose the oxygen, so CuO is reduced. Okay, and then we have another explanation, right? So carbon caused CuO to lose oxygen. So carbon is the reducing agent. Right, it caused CuO to be reduced to lose oxygen. Okay, so repeat ourselves. Carbon is oxidized to CO as it gains oxygen. Okay, so since it gains oxygen and since your carbon is oxidized, it is the reducing agent, right? Why is it the reducing agent? Because your carbon caused the CuO to be reduced as it caused it to lose the oxygen. Okay, and then my CuO caused carbon to gain oxygen. So CuO is the oxidizing agent and CuO loses the oxygen to form Cu, so it is reduced. Okay, in terms of electron transfer, explain the oxidizing agent and the reducing agent. So Mg, write your half equation because we are forming the using electron transfer to explain it. Okay, so Mg give me Mg2+, like the magnesium metal piece give me magnesium sulfate in the compound. Okay, so Mg form Mg2+, then this part you have to add 2 electrons. Okay, so your neutral magnesium gives you magnesium ions because this is your magnesium ions in the compound, right? And magnesium ions has a 2+, the 2+ will be evened out by the 2 electrons. Okay, so this is one of your half equation, and you have the next one, which is copper sulfate. Inside is my Cu2+. Okay, this part it will gain 2 electrons to give you. Okay, using the same idea, right? My copper 2, because it's in a compound with Cu2+ inside, it gains 2 electrons because 2+, you have to add 2 negative to become neutral. Okay, so these are the half equations that's actually happening. So let's explain it out again. So my magnesium lost 2 electrons to form Mg2 plus. So remember your redox definition: gain, lose, lose, gain. So gain oxygen, lose hydrogen, lose electrons, and then gain oxidation state, right? So this is my oxidation definition, right? So my magnesium lost 2 electrons because when you gain on the product side, this side, you actually have to lose the 2 electrons. Okay, so my magnesium lose 2 electrons. As a result, the magnesium is oxidized. Okay, magnesium cause your copper 2 plus to gain 2 electrons. So magnesium copper cause copper 2 plus to gain. Reduction is gain, right? So magnesium cause copper 2 plus to be reduced, right? By gaining 2 electrons. Okay, so magnesium is oxidized, it undergoes oxidation, but magnesium causes the reduction. So magnesium is the reducing agent. Right, from this explanation, it follows your trend of something that is oxidized is the reducing agent. Okay, on the other side, looks at your copper, my Cu2 plus gain 2 electrons to form Cu. So the Cu2 plus, when it gains electrons, it will be reduced because reduction is gain, right? And then what caused it to be reduced? The Mg caused your okay, so Cu2 plus is being reduced. So Cu2 plus cause your Mg to lose the electrons. Okay, so the Cu2 plus, because it have to gain 2 electrons, it cause your magnesium to lose the 2 electrons. So Cu2 plus is the, when it cause you to lose, it is the oxidizing agent because oxidation is lose, oil-rich. Right, it causes magnesium to lose, so it causes magnesium to be oxidized. Okay, so using this example over here, you can see that your copper is reduced and your copper 2 is reduced and the copper 2 is the oxidizing agent. Okay, we definitely need time to break down and analyze this. The more you practice it, the easier it will get. Okay, break it down bit by bit logically and don't try to memorize. Your life will be very difficult. Okay, the last example is in terms of oxidation state. Identify and explain the oxidizing agent. Okay, so oxidation state, let's count your oxidation state or write all the oxidation state down first. My copper is definitely 0, neutral. This one, because of your formula CuNO3 your copper is plus 2. Okay, so what can we count over here? Right, you can see your copper increases oxidation state from 0 to plus 2. Right, so increased oxidation state is oxidized. Okay, let's write this one down first. Okay, so my copper, this is the element itself. So copper increases its oxidation state from 0 in Cu. So this is the element that I'm talking about. This is the substance. In this case, it's just the same copper. Okay, increases from 0 in Cu to plus 2 in Cu NO3 2. So the oxidation state increase from 0 in the element or in your starting material to plus 2 in the product side, which is your copper nitrate. Okay, so what happens? Your copper is oxidized. And by the logic, since it is oxidized, the copper is the reducing agent. Okay, let's see what other things do we count. So in this case, in this compound, when you look at the compound like that, right, you have to know H is always plus 1. O is always minus 2. So what do we count? We count the N. Remember, we count your non-metals and your transition metals. Your non-metals that are not group 7, we count it. Okay, so in this case, I have to count my nitrogen. So how do I count? Plus 1 plus X plus 3 times of minus 2 equals to 0. So plus 1 is hydrogen's oxidation state. X is the one that I'm trying to count. And 3 times of minus 2 because there's 3 oxygen atoms. Okay, so if you count it out, X will be minus 6 plus 1 is minus 5. X will be plus 5. Okay, so for nitrogen in this nitric acid, your oxidation state is plus 5. And because this is a nitrate, this is also a nitrate, it's the same thing, you don't have to count. So I should count this one instead, the NO2. So using the same example, X plus 2 times of minus 2 equals to 0. The whole thing, NO2, is neutral. Okay, N is the X, the oxidation state that I'm trying to count. 2 times of oxidation state of oxygen minus 2. So X equals to plus 4. Okay, so from plus 5 become plus 4. There's a reduce in oxidation state. It is being reduced. Okay, so how do we explain this out? Yeah. So first one is to state the element. So nitrogen decrease its oxidation state from plus 5. Where is it plus 5? In HNO3, your starting material, to plus 4 in NO2, your product side. So what thing is being reduced is the HNO3 is being reduced. Okay, HNO3 is being reduced. HNO3 causes your Cu to be oxidized. So HNO3 is the oxidizing agent. Okay, this is a standard format to use when you explain oxidation state. Okay, the element, the oxidation state, what happened to it? Increase or decrease? From what number in what starting material? From what number in what starting material to what number in the product? To what number in the product? Okay, so what is being oxidized or reduced? It can only be your starting material. It can never be the products. Products are the result of redox reaction. Okay, what is being oxidized or reduced can only be your starting material. Okay, please know that when we count the oxidation state, example this 4HNO3, I'm only interested in the compound itself, meaning to say the HNO3. These 4 outside have no meaning. Okay, please don't go and put a 4 somewhere and then times it. there is no meaning to this 4 because I'm only interested in the oxidation state of the element in this compound. I don't care how many is there. There is no meaning for the 4 in redox reaction.